Hello guys, welcome to another video. This one is paper 1-2 of November 2011 for Add Math paper 1. Now with that being said, let's move on to question number 1. So here what do we have? We have to show the left hand side is equal to the right hand side. Now as always, we want to proceed step by step. So first thing first, what is tan theta and what is cot theta? So let's write this down so we know exactly what are we working with. So by definition, tan theta is equal to sine theta over cos theta. Now again, by definition, cot theta is what? Cot theta is simply cos theta over sine theta. Now in the question, if you observe, what do we have? We have on the bottom, let's first have a look at the denominator. We have tan theta plus cot theta. So tan theta is sine over cos plus cos over sine. So let's try to first simplify this. Now, how do you combine two fractions which have different base? So we have to find the LCM. Basically, multiply them by each other. That's one way to do so. You will have sine theta, cos theta. Then we have to cross multiply. You will have sine square theta plus cos square theta. Okay, so now we know this from our list of formula. This has to be 1, right? That is your identity functions or equation. That's what we know from our list of formula given to you right here, as you can see. So now moving up, what do we have now? So if you simplify, that will be 1 over sine theta cos theta. Now next step, bring this back in our main equation. So if you observe, right now what do we have? We have 1, this is a 1, over, this is this, sine theta, cos theta. Okay, so now we have to simplify this. So the idea is that 1 divide, so when we have divide, we can change that to multiply, and then flip this upside down to simplify. So this is what we do. And then finally, if you just multiply, you will have sine theta cos theta. Okay, so the idea is that I think from paper 1 math we learned this. So for this part, for example, if you have A over B divided by C over D, for example, right? Now, to solve this, we can change this symbol to multiply. So change to multiply. This first one remain the same, which will be A over B. And this one we have to flip upside down for this one. So that will be AD over BC. So same concept applies here. As you can see, here we have 1 on top. 1 is 1 over 1 divided by 1 over sine cos. So we change this sign to multiply. This one remained the same, and we have to flip this upside down. Now if you multiply, you will get sine cos. So that's the main concept for this part. But this is shown as required for question number 1. Show the left hand side is equal to the right hand side. That is 3 marks for this question. Now let's move on to question number 2. So here we have to find the coordinates of the point where the line, so where the line meets the curve, this curve. So basically we have a straight line, and then we have a curve. Let's say curve is this way, whatever the shape it is. We have to find the points of intersection. Now, how do you find the points of intersection? We have to solve simultaneous equation. This is my equation number 1. This is my equation number 2. That makes sense, right? Now we have to make x become subject because that's the easiest one to do. You will have 2 plus 1. Now replace this x back in this equation. So you will have x squared. What is x? X is this, right? 2y plus 1 square plus y squared equal to 29. Now let's simplify this. Expand, you will have 4y squared plus 4y plus 1 plus y squared equal to 29. Now let's send everything to one side. You will have what? You will have So first let's simplify this. You will have this plus this, that will be 5y squared plus 4y plus 1 minus 29 equal to 0. Now you have 5y squared plus 4y minus 28 equal to 0. Now we can try to factorize this. Let's see what happens. So what is 5y squared? It is 5y times y, right? Now 28 can be what? Let's see. 28, let me write this here. 28 can be 1 times 28. Can be 2 times 14. Can be what else? 4 times 7, right? So as you can see, we can choose between this list, these two numbers, these two, or these two, to put here so that we get plus 4. Now we have to see which one makes sense. So what if I choose this one? Right? Let's try. I can put 2 here and 14 here. If you observe, 5y times 2 is what? It is 10. Now we have to have plus 4 here. We can have minus 10 here and plus 14. So plus 14 minus 10 is plus 4. So now if you can solve, this is a good factorization. Now the thing is that if you don't know how to factorize, you can always use your formula. As you can see, to find the value of a quadratic equation, you can use this formula. So no need to panic. You can always use this to find the value of y or x for a quadratic equation. Now y will be what? Will be minus 14 over 5, and y will be 2. Now for each value of y, let's find the corresponding value of x. So let me simplify this first. Minus 14 divided by 5, that should be minus 2.8. Now, we know that x is this equation, so replace your y here to find the corresponding value of x. So x will be 2y, will be this one, plus 1. 2 times minus 2.8 plus 1, that will be this. And this here we have x equal to 2 plus 1, that will be 5. So now the 2 points, as you can see, the points of intersection. The first point will be minus 4.6 minus 2.8, and then we have the point 5 and 2, right? You always have to write down the x value and the y value, okay? X value and the y value. So these are the points of intersection between the line and the curve solved by simultaneous equation. So whenever you have points of intersection, if you see cuts, meets, we are always leading to solve a simultaneous equation. So that's the main idea behind this question. Now that was question number 2. Let's move on with question number 3. Now we have to express log x2 in terms of a log to the base of 2. Pretty easy. The main idea is that, let's say we have log a and b. Express this in terms of log base 2. So we have to rewrite everything down. So first we have log base 2 because we want to have 2. Then we take the first value, divide by log base 2 with a. That's the main idea. So here we have log base x2. So that will become log base 2 over log base 2 of x. That will become 1 over log base 2 of x. So this is your answer for part 1. So you have to know this: when you have log of the base and of the same value, it will become 1. Okay, so that is part 1 of the question. Now for part 2, using your answer from part 1 and using this, we have to find the values of x which satisfy this equation. So we have to use this answer right here and then use this substitution to solve this. So one by one, let's have a look at this equation. Here we have u is log this base x, or base 2x. Here we have this, so we can replace that by the value of u, right, if that makes sense. It is 3 minus. Now if you observe, here we have minus 2, and here we have log x2, right? So we know from part 1 that log base of x2 is equal to 1 over this. So we can simplify. That is simply 1 over log 2x. That is from part 1. As we have seen, this became this. So this will become this. Now replace. This will be what? Will become u. So we have what? We have u is equal to 3 minus 2 over u. Now let's multiply by u everywhere because you want to eliminate this value at the bottom so that we can have a good equation to work with. You will have u squared is equal to 3u minus 2. Now send everything to one side, you will have what? U squared minus 3u plus 2 is equal to 0. Now we can factorize this. Let's see what happens. How become u times u. 2 is simply 2 times 1. Now to get minus 3, we have to have minus 2 minus 1. So now u is equal to 1 and u is equal to 2. Now again, we're not trying to find the value of u here. We are trying to find the value of x. So u, as we have seen before, it is log to the base of 2x. So replace that back in these two values right here. So here we have log base of 2x is 1 and log base of 2x is 2. So x, we just have to send this over here. You will have 2 power 1. X will be 2 power 2. Here will be 2 and here will be 4 as your answer. As you can see, we have two values for x for question part 2. Solve step by step using the answer from previously to help you find the answers for x at the end. That is question number 3. Now let's move on to question number 4. So here we have a curve have equation y equal to this, okay, given to you. Find the equation of the normal to the curve at this point. So if you don't understand the question, no problem. So what can you do is draw something so you can understand what you're trying to find exactly. So example, we have a curve. Now you can draw a curve just like that. Just need to be a curve. We don't know what's the shape, but this one is a curve. Now we have to find the equation of the normal to the curve at the point x equal to 2. For example, let's say that's the point x equal to 2. Okay, now what is the normal to a curve? It is a line which is perpendicular to that point on the curve. For example, here will be the line. Okay, and for example, let's say we had a line here, the tangent to that point, for example. Right? So the angle between these two has to be 90. So our goal is to find the equation of that normal of the green line. Now, as you can see, the green line and the normal line is a straight line. So how do you find equation of a straight line? We have to find the gradient of normal, right? Now, to find this gradient, we have to first find the gradient of tangent. This is tangent. Why? Because here, we can find this more easily than this, at least at first, by using the curve equation, because we know that the gradient of tangent is simply dy by dx at the point x equal to 2. So using this idea, let's go and find the gradient of tangent first. So right now we have y is given to you by this, so we have to find dy by dx. First step, we have to multiply by the power 2 over 3. That will be 3x squared plus 15. Then we have to minus 1 to the power. That will be minus. So 2 over 3 minus 1 is minus 1 over 3. Then multiply d by dx of the value inside. That will give you 6x. Simplify 3. That will be 2. And this will give you 4x over, you can bring this down. That will be 3x squared plus 15, 1 over 3. Now, obviously, we want to find this value at the value of x equal to 2. That will be what? Let's replace back in the equation. You will have 4 times 2 is 8 over 3 times 4 is what? Let's see. 12 plus 15, that will be 27. So 27, 1 over 3. So power 1 over 3, that should be 3. So 8 over 3. Okay, that is your gradient of tangent at that point. But now, we don't care about this one. We are trying to find the gradient of normal. So we have to know something here is that they are related to each other by this equation, which is, if you take the gradient of normal, multiply to gradient of tangent, you have to get minus 1. So that is the formula we have to know when dealing with these two. Then we place in the main equation. Let's see what do we have. Gradient of normal, we don't know. We're trying to find that. Okay. Multiply by this one. We just see this. It is 8 over 3 equal to -1. So solve. You will have gradient of normal has to be -3 over 8. So this is how we derive the gradient of normal. Now, to find the equation of a straight line, we have to have the gradient, but also we have to have a passing point. So passing point, very easy. If you observe here, we have the value of x equal to 2. So we know that that point have x is 2, but we have to find the value of y. So how to find the value of y? Replace x in your equation of y right here. So let's see, what do you get? That will be 3 times, so that will be 3 times 4 plus 15, 2 over 3. That will be 27, 2 over 3. That should be 3 power 2, that should be 9. So of course you can always check using your calculator. Power 2 over 3, that will be 9. So as you can see, the passing point is 2, 9. So we can use this passing point and this gradient to find the equation of the normal. So the way is, we take, this is your x value, this is your y value. So we take y on top minus the corresponding y value, and the x minus the corresponding x value equal to the gradient of the normal. This is how you find the equation of a straight line at least. Now we cross multiply, you will have what? 8y is equal to -7,2. Of course, you can always double check. 9 times 8 is 72. And then equal to -3x plus 6. Simplify, that will be 8y has to be -3x plus 80. And this is your equation of normal line to the curve at the point x equal to 2. So one thing I realized here, I actually also made a mistake. If you observe, very stupid mistake. So the lesson from this is, always double check with your calculator, because 6 plus 72 is what? It is not 80. It has to be 78. So the answer will be 8y minus 3x plus 78. So you see, these are the silly mistakes you have to avoid in your exam. So always use your calculator. But as usually, I think for me, what I do, because I do the paper pretty fast, I always have time to check. I think that should be your goal. Every time, double check your answers so you don't make silly mistakes. Now, let's move on to the next question. Here we have question number 5. So here we have two variables, x and y. When y square is plotted against 2 power x, as you can see here we have 2 power x and here we have y square. Usually, what do we know? Usually we take y against x. That's the most, in most situation, and you will get, this is your y-axis and this will be your x-axis. Now because here we have y square against 2 power x, that's why we have this here and this here. That's the idea that we have to understand. Now, a straight line graph is obtained. As you can see here, this is the straight line graph. This line has a gradient of 5. That's good to know. The gradient is equal to 5, okay? And it passes through this point. This is the passing point. Okay, now part 1. We have to express y squared in terms of 2 power x. So we have to find the equation of that straight line. So pretty easy. We have a passing point, that will be this, and we have the gradient. So to find the equation of a straight line is pretty easy. Now, we have to understand, usually that will be x, but here because it is 2 power x, that will be this, and here that will be y squared. So what you will have now is, same steps, y squared minus its corresponding value over 2 power x minus its corresponding value have to give you the gradient. Now we have to cross multiply. You will have y squared minus 81 has to be 10 times 2 power x minus, sorry, it's not 10, 5, it's 5 actually, not 10. My apologies. It's 5, and then 16 times 5 is what? It is 80. So y squared equal to 5, 2 power x minus 80 plus 81. So finally, we conclude that y squared has to be 5, 2 power x plus 1. This is your equation of y squared in terms of 2 power x. That is part 1 of the question. Now let's move on to part 2. So here we have to find the value of x when the value of y is 6. So replace back in this equation. As you can see, it's pretty easy to do that straightforward. So y is this, y squared will be 36. That will be 5 to power x plus 1. Now simplify, let's make this one become the subject. So 5 to power x, that will be 35. So 2 power x, that will be what? That will be 7, right? Because 35 divided by 5 will be 7. So divide by 5 everywhere here, if that makes sense. Now, as you can see, the x is on top. We want to bring the x down. How can you do that? You have to apply ln on both sides. Okay, ln of both sides. Now we can bring this down by using the properties of logarithm. That will give you x ln of 2 is ln of 7. So x has to be ln of 7 divided by ln of 2. Now this can be your answer definitely, or if you want to, you can simplify ln of 7 divided by ln of 2. That will give you 2.81, correct to 3SF if you want to, but this one is the exact value of x when y equal to 6. And that is your question number 5. Let's move on to question number 6. So here we have given that this expression equal to a plus bx squared plus cx squared. Find the value of a, b, and c. So the thing is that sometimes when we have this kind of question, we try to think we have to use any shortcut, anything that can simplify our life. But honestly, you know what? You can always proceed as usually and solve one by one and see what you get. Don't stress yourself. Always proceed step by step. Even if that takes, let's say, 3 minutes longer, that is okay. Who cares? So simplify this. So you have 5. Choose 0, right? That will give first term is 3, and we have x. 0, that will be 5. 5, choose 1, that will be 3. X, that will be 1, 4. Plus 5, choose 2, that will be 3x. 2, 3. 5, choose 3, that will be 3x. That will be 3 and 2. Plus 5, choose 4, that will be 3x. 4 and 1 plus 5, choose 5, that will be 3, and that will be x, that will be 5 and 0. So simplify, let's see what do we get for the first one. That will be what? 5 choose 0 is 1, that will be 3 power 5, that will be what? That will be 243. Here we have 5 choose 1, it's 5 times 3 power 4 is 45, that will be x, that should be 10. 3 power 3 is 27 times 10, which is 5 choose 3, sorry. So 5 choose 2. So 5 choose 2 times 3 power 3 is 270. That will be x squared, and then here we have 5 choose 3, it is 10 also, times 9, that will be 90. 5 choose 4 is what? That will be 5 times 3. That will be 15. And then here we have 5 choose 5 is 1. That should be simply x power 5. Now this is when you expand this one. Now very similar. Here the only difference is here we have minus and here we have plus. So the idea is that for the odd terms it will become something like this. So for the first one it will be the same thing. That makes sense, right? Now this has to be minus 4 or 5. Now here we have plus 270 minus 90 and plus 15 and minus x power 5. So if you guys don't understand this, no big deal. Expand this the same way I did for this one. You will get these terms. That's the main idea behind. It is okay if you don't go with shortcuts. It is always best to take your time. You have time to solve the questions one by one. Now we have to add those two, so add. Let's see what happens. So these will cancel out. So you'll be left with 243 times 2, that will be 486. And then we have what? This is 270 times 2, 540 x squared. And here we have simply 30x power 4. As you can see, by comparing those two equations, A has to be this has to be B, and this has to be C. That is part 1 of the question. Now part 2, what do we have? It says hence. Now whenever you see hence, it means we have to use your answer from part 1. Using this substitution, solve for x. Now as you can see, we know this is equal to what? This is equal to this one already. That's why it says hence. Replace, you will have 46 plus 540 y squared plus 30, that will be 1086. Now we have to use substitution for this one. Now let's see how can we use that. So x squared is equal to y. Now we have to know x power 4 is what? It is x squared square, which is equal to y squared. So that's how we will use that substitution. So here we have 46 plus 540, x squared is y, plus 30, that will be y squared, is 1086. Now let's send everything to one side. You will have 3, so 30, 540, y, and here we have plus, but you have to send this over here, become minus, right? Minus 1086, that will become minus 600. Let's try to simplify. As you can see, we can divide by 10 everywhere, so this will go away, away and away. Now we can divide by 3 everywhere. It will become y squared plus, that will be 18 minus 20 equal to 0. Now let's see how can we solve this. Can we find the factorization? We have, this will be a 1 times 20, 2 times 10, 4 times 5. As you can see, we cannot factorize because none of the values make sense. Let's use our equation. So we can use y equal to minus 18 plus minus root of 18 squared minus 4 times a and times b. That will be 404. Divide by the value of 2a, that will be 2. So let's solve one by one. Y will be what? For the first value, we have minus 18 minus root of 404 divided by 2. That will be minus 19.05. Now next one is what? Y is equal to minus 18 plus root of 404 divided by 2. That will be 1.05. Now obviously in this case, we're not trying to find the value of y. We're trying to find the value of x. As we have seen, y is actually x squared is equal to this value, and here we have x squared is equal to 105. As you can see, this is not possible because if you would find the square root of a negative value, it is invalid. Now for this one, we can solve. X has to be plus minus root of 1.05. That will be 1.02 as your answer. So plus minus 1.02 as your answer for question part 3 of 6. And that is the question. Now let's move on to question number 7. So here we have what? Here we have to solve the equation. We have to show this equation can be written as this. Okay, pretty easy. Let's just break this down. So as you can see on top, what do we have? On top we have a equation that we can simplify. Let's simplify. You will get 16 minus 8 root of x and plus x. Now let's replace this back in here. You will have what? Now you have to understand what is this. This is simply x power half, right? That's the main idea here. Now let's do that. On top you will have 16 minus 8 x power half plus x over x power half. Now let's break this down. You will have what? 16 over x power half minus 8 power half over x power half plus x over x power half. Now simplify. For the first one, pretty easy. That will be 16. We can send this up. That will become x minus half. Here, this will cancel out. Minus 8. And here you can see, pretty easy, because this is 1. We have to use the laws of logarithm. For example, when you have the base of a, here we have 2. When you have the base of a, we have 1. What can we do? We can bring this up. That will become base of a, same base, 2. Because we have divide, become minus 1. That will be 1. So same idea here. We have the same base. You will have plus here, base x. Here we have 1. Here we have divide become minus half. So simplify. In the end, you will get 16x minus half minus 8 plus x half. Okay, this is shown as needed. This is P, this is Q, R is just 1. That's all for this part 1 of the question. Now for part 2 of the question, let's see what do we have. A curve is such that dy by dx is given by this. Okay, this is given to you for x is more than 0. This is the domain of that function. Now given that the curve passes through the point, we have a passing point right now, we have to use it somewhere. We have to find the equation of the curve. Now we have to understand, equation of the curve is the value of y. We have to find the value of y from dy by dx. So this comes from the understanding that to find y, we have to integrate dy by dx. That's how we will find y, because y is the equation of the curve. So let's solve that. So y will be, that will be this. So this, what can we do with this? If you realize from part 1, we know this is equal to this. So let's use that. It's much easier. That will be 16x this minus 8 plus x power half. That will be dx. Simplify. That will be 16. Now we have to plus 1. That will become half divided by half. Now we have to 8. That will be x. And here we have x 3 over 2 over 3 over 2. Now plus c, obviously, and that will be y. Now the point is 9, 30. We have to use the passing point. This is your x value and your y value to find the value of c. But let's first try to simplify this some more. Let's see what happens. Y, that will become 32. X power half minus 8x. And plus 2 over 3x. 3 over 2 plus c. Replace these values back in the equation. Let's see what do we have. So y is equal to 30. That will be 32. That will be 3 minus 8 times 9 plus 2 over 3. That will be 9. 3 over 2 plus c. Simplify. Let's see what happens. So here you will have 30. 32 times 3, that will be 96 minus 7, 2, 9 power 3 over 2. That will become this times 2 over 3. You will have 18, so plus 18 plus c. So simplify. C will be what? So first, we can simplify this. 96 minus 7, 2 plus 18. Then we have 30 minus the answer. That will be minus 12. So in the end, we have to show the value of y. Now you can see y is simply your equation of curve. That will be this, minus 12. This is your equation of y. Obviously, you don't need to do that symbol. You can always write this in this way and write minus 12 as well for your answer. And that is your question number 7. Let's move on to question number 8. So here we have the line CD is the perpendicular bisector of the line joining the points A and B. So let's first draw something so we understand what's happening. For example, let's say here we have the point A and here we have the point B, for example, right? Okay, that is A and B. Now, what does it mean to be a perpendicular bisector? It means that we pass through the midpoint of AB, that's the first thing, the midpoint, and it passes at the angle of 90 degrees. So that is what is a perpendicular bisector of the line AB. This is your line CD. So now we have a drawing. We understand exactly what's happening. We have to use that drawing to find the following answers to my question. We have to find the equation of CD. CD is this one. Now, as you can see, CD is a straight line, so we first have to find the gradient of CD. Now, as you can see, we don't have much information on CD, so we have to first find the gradient of AB to find the gradient of CD. Because what do we know? Because if you have two perpendicular lines, as we have seen before, gradient of CD multiplied by gradient of AB have to be minus 1. So this is the main equation or concept we have to use to find that gradient. So let's first find this one. Gradient of AB will be what? Will be using those 2 points given to you. So y2 minus y1, so minus 5 minus 3 over x2 minus x1. That will be this. Minus 8 over minus 6. That will be 4 over 3. Now from this, replace this back in your equation. Conclude that gradient of CD have to be minus 3 over 4. Now we have this. Now we have to find this passing point to find the equation. So M, as you can see, it is just the midpoint of A and B. So very easy. Use your formula to find that. That will be x1 plus x2. That will be what? Minus 1 plus 5 is 4. Divide by 2, that will be 2. Minus 5 plus 3 is minus 2. That will be minus 1. Divide by 2, minus 1. So this is the passing point M. That will be x and the y value. Now we can find the equation pretty easily. Y minus its corresponding value. Then we have yx minus 2 has to give you the gradient. Now cross multiply, you will have 4y plus 4 has to be minus 3x plus 6. Now 4y, that will be minus 3x plus 6 minus 4. Now 4y equal to minus 3x plus 2. And this is the equation for part 1, which is the line of CD. Now let's move on to part 2 of the question. So here we have given M is the midpoint of AB. Okay, so that's something new now. But as we have seen before, the midpoint of AB is what? M. We have seen it is given, it was found to be 2 minus 1. Okay. And such that we have this equation, which is true. 2cm equal to md. Now the x value is minus 2 of c. Find the coordinates of d. Now, because we know the equation of CD, as we have seen from part 1, it was found to be 4y equal to minus 3x plus 2. When the x value of c is minus 2, so when x, that will be c, is equal to minus 2, let's find the corresponding y point. That will be what? Replace back in your equation. That will be 4y has to be 6 plus 2, and that will be 8. So y has to be 2. So the point C has to be minus 2, 2. That is the point C. Now we have to use that information to find the, and this as well, to find the point D. Now, let's write this down again. How can we simplify this? We have 2cm equal to md. Now, 2 is 2, right? Now, what is cm? As we know by vector difference, it is om minus oc. Now, if you don't understand this, no big deal. There's a video on my channel. Just type in vectors, you will see something explain to you why is this the case. But it is like that, okay? Now, this will be OD minus OM. Now, let's simplify. So here we have what? We have 2. 2 is 2. Now we have OM. OM is the midpoint. That is 2 minus 1. OC. OC is this one, minus 2, 2. And OD, we don't know. We're trying to find that. Minus OM is 2 minus 1. So simplify. That will be 2. That will be 4 minus 3. And that will be OD minus 2 minus 1. So simplify. OD has to be 8 minus 6. Simplify this, right? And send this over here, become plus 2 minus 1. That will become 10 minus 7. So basically, the point D has to be 10 minus 7. Okay, so that will be my coordinates of D. Now for part 3 now, we have to find the area of triangle CAD. Okay, let's see what do we have. CAD will be this triangle, right? So the idea is that how would you find area of triangle? You can use half time base time height. So this is the height, AM, and the base is this one, which is CD. You can use that, or simply we can always use the formula. Sometimes we're just too lazy to find the length. We can just go back to using the formula. For example, we have C is the point minus 2, 2. A is the point given to you by minus 5, sorry. And then D we have found it is 10 minus 7. So using the 3 points, we can use the formula, which is the array method. Area has to be half modulus. The first point is minus 2, 2, minus 1, minus 5, 10, minus 7. Now, when you begin with a point, you have to end with the same point. That's the formula we have to use, and then we have to simplify. Now, first we have to multiply in this direction. Half. That will be 10 plus 7 plus 20, right? Because minus minus become plus, right? That's the idea. Then minus, we have to multiply in this direction. That become minus 2, minus 50, and plus 14. Simplify. That will be half. 10 plus 7 plus 20, that will be 37. Minus. Here we have minus 2, minus 50, plus 14, that will be minus 38. Now simplify. We have 37 minus minus 38 divided by 2, that will be 37.5 as your area units square. Okay, that is your question number 8. Okay, let's move on to question number 9. So given that y equal to this equation, find dy by dx. So pretty easy. The first thing we have to observe is what? It is a product, x times this. So we have to use the product rule. So dy by dx has to be, we have to first write down the first value, then d by dx of this one, that will be cos 4x times 4, then plus the second value, then times d by dx of the first value, that will be 1. Simplify, that will be 4x cos of 4x plus sine 4x. So this is dy by dx of that value using your product rule. Now for part 2, hence, as you can see, hence means we have to use the first equation to find that, right? Now let's see, what do we have. We have to understand that integration is the reverse process of differentiation. So what do I mean? I mean is that if you were to integrate this value that we have here, that we have just found, we have to understand that basically you will get the same value as before, which is this one. That's what we have to understand. Now we are here, we are trying to find this value only. So we have to make this become the subject of formula. That's the main idea. So let's do that one by one. So first we can break this down. That will become 4x cos 4x dx plus, break it down, sine 4x dx equal to x sine 4x. Now try to make this become subject of formula. So one by one, let's first send this one on this side, right? You will have integration 4x cos 4x dx has to be x sine 4x minus sine 4x dx. Now simplify. Here we have the value of 4. We have to eliminate that, so we have to divide by 4 everywhere. I mean, we have to send this, everywhere, basically. So let's do that. You will have x cos 4x dx, that will be x sine 4x over 4 minus 1 over 4 sine 4x dx. As you can see, here we are trying to find this value as this, and then we just have to integrate that for the final part. Let's see, what do we get. We get x sine 4x over 4 minus 1 over 4, and this will give you something you have to know. Integration of sine, it give you minus cos 4x, right? Then divide by d by dx of the value inside, that will be 4, and plus c finally for your answer. Now simplify everything. Let's see, what you have. You will have what? X sine 4x over 4, that will become plus cos 4x over 16 plus c. This is the integration of this by using the answer from part 1. Now we have to use that, evaluate this. So basically here we have to replace the values of x to find that integration. So let's do that. So this will become Now C is optional here. I mean, yeah, you have to put C because here we have this part, we have to put C. So pi by 8, 0, x cos 4x dx, so we have to replace, that will give you what? So for this one we don't need C because here we have limits, so C will cancel out, we don't need that part, we just need to replace the values in here. So here we have x, pi by 8, that will be sine pi by 2 over 4 plus cos pi by 2 over 16 bracket, and then we have to minus, here will be 0, here will be cos 0 over 16. Let's see what do we have. Because the values is pi here, we have to use radian. Okay, that makes sense. So we have sine pi by 2, that will be 1, so this becomes 1. So let me find some space here. If you continue on this page, you can see that this will become what? Pi times 1 over 4 plus this will become what? So here we have cos pi over 2, that becomes 0 minus 1 over 16. Simplify, that will become pi over 32 minus 1 over 16. Now of course we can simplify this if you want to. Become the same base, that will become pi minus 2. This is your answer for that integration. Okay, that will be your question number 9. Now let's move on to question number 10. Here we have to solve the equation, basically to find the values of x. But first let's try to simplify to see what can we do. So if you go check out your list of formula, let's see what do we have to use from that. So let me find that first. It should be somewhere over here. Okay, so here I have it. You can see we can use this one, right, in that question. So let me write this down. So sec square x, so x has to be 1 plus tan square. This is given to you, so we have to use this identity to solve this equation. Now, here we have this. We can replace this by this. You will have 2, 1 plus tan square x. So this is x, sorry, not a, because here we are having the values of x here. That's why. That will be 5 tan x plus 5. Now let's simplify. You will have 2 plus 2 tan square x is equal to 5 tan x plus 5. Send everything to one side, you will have 2 tan square x minus 5 tan x plus 2 minus 5 equal to 0. So simplify. 2 tan square x minus 5 tan x minus 3 has to be 0. Now we can simplify. So here we have 2 tan x, or factorize, that will be tan x here. 3 is 3 times 1, 3 times 1. Now to get minus 5, we have to have minus 6 plus 1. Right? So tan x have to be minus half. Tan x has to be 3. Now this is just factorization. Again, if you don't know how to factorize, to solve for that value, you can always use your quadratic equation. Okay, that is part 1. Now let's solve them one by one. So let's solve this one first. When tan is positive, what happens? You know that it has to be in the first quadrant and in the third quadrant. This is basically your value of x, and this has to be 180 plus x. So x will be tan inverse of 3. So we have to use degrees here, sorry. Tan inverse of 3 have to be 71.6, that's my first value, and then we have to add 180 to that. That will be 251.6. That is the other value of x. This and this. Now moving on to this part, as you can see, here we have a negative value. So we have to know when it is negative, it has to be in this quadrant and in this quadrant. This is basically the value of 180 minus theta, and this is the value of 360 minus theta. Now because it is negative, I will use a fake angle theta first to find those values. So theta has to be tan inverse of positive half. Here we have minus, but theta is not your answer. We have to use this trick to find that first. So theta will be what? tan inverse of 0.5, that will be 26.7 or 0.6, sorry. But that is theta. We don't care about theta. We have to find x. X is found according to your quadrants. As you can see, it is 180 minus this. So 180 minus 26.6, that will be 153.4 degrees. And also, it is 360 minus 26.6. That will be 333.4. So these are the answers that we have for x for that equation. That is your question, part 1 of 10. Now for part 2, here we have to solve this equation between 0 and 4 pi radians. So let's see how can we solve this one by one. So first step, we have to make sine become subject. Y over 2 plus pi by 3 equal to 1 over root 2. Now as we can see, sine is positive. It will be first quadrant and your second quadrant. First is simply the value of the angle here. Let's call it x for now. And here we have what? We have the 180 minus x, or we can think about radians, pi minus x, same thing. Now let's solve one by one. Because it is positive, I can just do this directly. So take the value inside, which is the angle, has to be sine inverse of 1 over root 2. So let's do that. Here it is degrees. Sine inverse 1 divided by root 2, that will be 45. So this is 45 degrees. But also we have to look at the quadrant. It can also be 180 minus 45, that should be 135. But of course here we have to use radians. So let's change that. So we know what? What do we know? We know that pi is equal to 180 degrees. And pi divided by 4 is what? 180 divided by 4, we know it is 45 degrees. So we can conclude that 45 degrees is pi by 4. And then 135 is simply pi minus pi by 4. That will be 3 pi by 4. So for now, what do we have? For now, we have this is equal to this. Right, let's see. How can we simplify this? So y over 2. So because the goal here is to find y, we have to try to make this become the subject of formula one by one. So let's first try to minus and see what happens. So LB, send this over here. You have 1 over 4 minus 1 over 3. That become minus pi over 12. And 3 over 4 minus 1 over 3. That become 5 pi over 12. Okay, so now you can see that this value here is negative. So what do we do in that case? We can change that because we can add plus 2 pi to make it become positive. That's the idea behind this. So you have to understand negative and positive in terms of angle. It is not really a negative value, it is a direction. So I think I've explained this before, but no big deal. The idea is that when you have a negative value and your domain it is positive, try to add 2 pi to see what happens. That's the idea behind. So minus 1 over 12 plus 2, that will become 11 over 12 pi. So from this we get this. Now finally, y has to be multiply everywhere by 2. You will have minus pi over 6. That will become 5 pi over 6. And this will become what? So become times 2. That will become 3 5 over 6. Now you can clearly see that this one is out of range. So wait, it is not. It is between 4 pi. It is still inside 4 pi. So we can keep this. That's the good news. Now this will go away. It is outside of the domain. So we end up with this value and this value because these two are inside the range. So if you can see, if you never plus the 2 pi, you will have missed this one value and you will not have gained your full mark. So the idea is that if your domain here is on the positive side, and if you solve, you see you have one negative value, try to add 2 pi to your value. Now if it was in degrees, you will add 360 degrees. So 2 pi and 360 are the same thing. It just that here we are working with radians. That's why we do that. And then solve for y, you have these two values, and these two are found to be inside this domain. Okay, that will be your question number 10. Now let's move on to question number 11. So answer only one of the following questions. but I guess, you know, we're doing both anyways, so no problem. So here we have first one, a curve have equation y given by this, right? At the point 0, 4 on the curve, the gradient of the curve or the tangent is this. Okay, so part 1, find the value of a. So pretty easy. If you observe, we have to use this passing point. This is your x value and your y value. Replace, you will have the y is 4, has to be exponential 0. A cos of 0 is what? It is 1. Let's check. Cos of 0 has to be 1. And then plus sine of 0 is 0. You can check using your calculator, obviously. That will become what? This is 1. That will be a. So a has to be 4. That is part 1 of the equation. The value of a has to be number 4. Now for part 2, we have to show that b is equal to 5. So now we have used this first information. Now we have to use the other part to show that this is the case. Now how are you going to show that b is 5? So you have to understand. Let's say we write this here for part 1. We know that a was given to you, was found to be 5. Now for part 2. Sorry, 4, not 5. What I'm saying 5. We have to show b is 5. Now we have given that the gradient of tangent is equal to 6. But now we understand that gradient of tangent is also dy by dx. So dy by dx at the value of x equal to 0, which is at that point, it is equal to 6. So using that understanding, we have to solve for value of b. How? Let's first find dy by dx. Let's do that. So y is equal to exponential this. This is 4 cos 2x plus b sine 2x. So let's find dy by dx. As you can see, this one is a product, this and this. We have to use the product rule. First thing first, write down the first value as it is, multiply by d by dx of this one. That will give you 1 by 1. Let's see, what do we have. Here we have 4, it is only a multiple, remain the same thing. Then d by dx will give you minus sine of 2x times 2, right? Here we have plus, here we have b as a multiple. And here we'll give you d by dx of this value will give you what? Cos of 2x times 2. Because of this value 2 right here. Now we have to plus, we have to write down the other value as it is, so which is this value. And then d by dx of this one will be minus exponential minus x. Now let's simplify to see what happens. Let's see, what do we get. That will bring you. So we don't even need to simplify y because we don't care about this. We just want to see this value. At the x value of 0, we have to get 6. So we know this is 6 when x is 0. So we place 0 here. That will be 4. That will be 0 plus b. That will become 1 times 2, because cos of 0 is what it is. We have to know, not to know, use a calculator. That will be 1. So this, we have this part, and then we have to add. That will be 4 of 1 plus 0, and that will be minus exponential 0. So simplify. 6 here, that will be 1. That will be 0 plus 2b plus 4 times minus 1. Simplify. That become 2b minus 4. Now 2b has to be, send this over here, 10. So b has to be the value of 5. This is shown as required. And as you can see, most of the times the answer you're trying to find is in the question itself. So we have to use the information given to you to find the answer. That's the concept behind in almost every question in math given to you in O-level and A-level. Now for part 3, we have to find the value of x, for which this is the domain given to you, for which y has a stationary value. Now, whenever you see this, a bell has to ring in your mind. The stationary value is simply at dy by dx equal to 0. So we have to know this concept. At the stationary value, we know this is true. So we have to use that to find the value of x. So let's write this down. So from the previous question, we have realized that dy by dx is found to be exponential minus x. Then we have 4 cos sorry, let me simplify again. This was wrong. That is exponential minus x, and that was minus 8 sine 2x plus 10 cos 2x, and then plus, this is minus e, this is this, and here we have 4 cos 2x plus 10 sine 2x. Okay, so this is dy by dx is given by this, and this is found from this part of the question. As you can see, we have solved dy by dx, we got this. Now just replace the value of b in here to simplify that to this. That's what we have right now. Now we know what, let me write this down. We know something is that at the stationary point, we know dy by dx has to be 0. That's the main idea here we have to use. Now equate that to 0, so we have what? We have exponential, this, on one side, plus 10 cos 2x. Now we can send this one to the other side, right? Because here we have negative. If you send this to the other side, it becomes exponential minus x. That'll become 4 cos 2x plus 10 sine 2x. Now, pretty easy. This one will cancel out. So on one side you will have minus 8 sine 2x plus 10 cos 2x is equal to 4 cos 2x plus 10 sine 2x. Now send everything to one side. Here we have minus 8 sine 2x. Send this over here. You will have what? You will have minus 18 sine 2x. Here we have plus 10 minus 4 has to be 6 cos 2x. Okay. Now, as you can see, whenever you have sine and cos in the same equation, what do? Divide by cos. The value is 2x here. Divide by 2x everywhere. Divide by cos 2x everywhere. Now, if you see, what happens is you have minus 18. Sine divided by cos will be tan 2x, and plus 6 has to be 0. Simplify. Tan 2x has to be minus 6 over minus 18. That will be 1 over 3, right? Send this here, divide by this, we get this value. Now, what we have right now, we have tan 2x has to be 1 over 3. As you can see, this value is positive, has to be in the first quadrant and in the third quadrant. This is your value of the angle, which is, here we have 2x. Let's write x, for example, doesn't really matter. And it is 180 plus x. Right. So 2x has to be tan inverse of 1 over 3. That will be what? Tan inverse. Here we have to use, I think we have to use radians, but let me see, what do we have for this one? That will be, let's use radians. That will be 0.322. But also we have the other value, which is pi, plus the value that will be 3.463. Now from this we have to find the value of x. X has to be 0.322 divided by 2, that will be 0.161, and then we have 3.463 divided by 2, that will be 1.73. Now let's check if that is between the required range. We have to find the value of x. X has to be between these two values as given by the question. It is 0 here. What is this value? So this is pi divided by 2. That will be 1.57. As you can see, this one is outside the domain, so we don't take this one. We can only take this one value. X has to be 0.161 for your value of x. As you can see, that is the only thing you need to find here. Find the value of x at that. So as you can see, in this case, you have to be very careful. It is a long question. Step by step is very important. And always remember to double check your answers so you don't make any stupid mistake to find this one value for your answer. That is your question 11 for either. So when you reach this value right here for your x value, I realized that I did something wrong. This is a stupid mistake. What I did was I miscopied my dy by dx. For example, here we had b. If you observe, b is 5. And guess what? I wrote 10. So that's what I did wrong here. That should be 5. So I can't copy sometimes. I don't know why. I'm just tired maybe. So if you were to solve, replace all the values here, that should be 5 here, and here that should be 5 obviously, and that should give you minus 13. And here you have minus 13 obviously, and that will give you this. That will be 6 over 13 instead of 1 over 3. Now, same steps follows. It's just that one of the silly mistake I made here. Now we have to find tan inverse in terms of radians. Obviously, that will be 6 over 13. That will become 0.432. So let's write this down. My first 2x value is 0.432. And then according to my quadrant, we have to add pi to that. So plus pi, that will be 3.57. So 3.57. Now x has to be obviously divided by 2. That will be 1.79, or it can be 0.432. That will be 0.216. As you can see, this one is outside your domain, and this will be your answer for the x value. That will be this value and not this one, because I miscopied this value from my other page. But yeah, you have to be careful with this kind of question. To O for the other part, for the last part of this question. So here we have a curve, have equation y. For domain x is more than 1, okay, given to you. Now part 1, we have to show dy by dx of this is given by this, where k is a constant to be found. So this one again, you can see it is a very long question. So we have to proceed step by step and always double check your answer at the end. So let's do this. So here we have y given to you by what? By ln of x squared minus 1 over x squared minus 1. X is more than 1. Now, this one is a fraction, as you can see. So you have to use the quotient rule. So dy by dx have to be what? First, we have to write down the denominator as it is. Then multiply by d by dx of the top value. That will be 1 over the inside value. Then multiply by d by dx of this one. That will be 2x. Then we have minus. We have to write the numerator as it is. Multiply by d by dx of this value. That will become 2x. Now everything divided by the base square. That will be x squared minus 1 squared. Simplify. This and this will cancel out, so you will have 2x minus 2x ln of x squared minus 1. Now everything divided by x squared minus 1 squared. This is dy by dx. Now let's try to simplify, because we have to show this in a way, right? So if we were going to write this in this fashion, so we can factorize 2x outside. You will have 2x. Here we have 1 minus ln of x squared minus 1 over the value of x squared minus 1 square. As you can see, this one is very much in this form, which is 1 minus the ln value over x squared minus 1 square. So 1 minus the ln value over this value. Here we have 2x, where the value of k has to be 2. And this is right here shown as required for part A. This is pretty easy for part 1. But it is very easy to make mistakes in these steps, so you have to be careful. Always proceed step by step. Now for part 2, we have to find the approximate change in y when x increases from this value to this value. So we have to know this. This is pretty easy. To find the approximate change in y, has to be dy by dx and the initial value of x given to you by root 5 multiplied by the change, which is p. So we just have to find one value here, which is this value, right? Replace x in here. You will have what? You will have 2 root 5 1 minus ln, that will be 5 minus 1 over, that will be a 5 minus 1 square times the value of p. Now simplify. That will be 2 root 5, that will be 1 minus ln of 4 over the value of 16. 5 minus 1 is 4 squared, 16. So that will be the exact value for the change of this. Now you can always simplify this to decimal place, and that should be okay as well. Now for part 3, find in terms of exponential the coordinates of the stationary point on the curve. Again, one more time, whenever you see this, what do we think about? We think about dy by dx has to equal to 0. So that's the main point, main concept we have to use for the part 3. So let's go for the last part of this question. So dy by dx is this 2x 1 minus ln of x squared minus 1 over 2 x squared minus 1 square has to equal to 0. Now next step, what do? Is we have to cross multiply. I think I need to drink some water, but it's okay. That will be what? 2x 1 minus ln of x squared minus 1. That will be 0. And because we cross multiply, 0 times this will be 0. Then we have to divide by 2x. We can do that. Let me see how many values we need to find. The coordinates. So there's 2 values we need to find. In that case, we don't divide by 2x because we will lose 1 value. Because as you can see, this has been factorized for you already at this point. Let me see if that counts or not, because here we can see that we have to find in terms of exponential. So if that's the case, we can divide by 2x, because there's no need for this part right here. Because if you were to solve, you will have 2x has to be 0, x is 0, so we don't need that. We need the value where we have exponential. So we can divide by 2x everywhere to simplify. So that will bring you to the values of 1 minus ln x squared minus 1 has to be 0. Now solve for this part. So this one we don't need that. As we can see, it is not exponential. That will be ln of x squared minus 1 has to be 1. X squared minus 1 has to be exponential 1, right? Now x squared has to be 1 plus exponential, x has to be plus minus 1 plus exponential. That is the x values for your point. Now we have to find the corresponding y values. We have to replace back in your main equation. So now we need some more space. So I will do this because this is the last part of the question. Why not? Let me do this for you. So we have been given that the equation of the curve is y. Y is given to you by what? By ln x squared minus 1 over s squared minus 1. Now x has to be plus or minus this value. But now, according to the question, we have realized something here, that x has to be more than 1, right? By this standard, x has to be more than 1. We realize that we cannot take the negative value. So from this, we can only take this plus value of 1 plus exponential. This is my x value for one of the points. Now, replace back in your equation, y will be what? Will be ln. Square will be 1 plus exponential minus 1 over square again, that will be 1 plus exponential minus 1. That will be ln of the value of exponential, right, over exponential. That will be 1 over exponential. Now the passing point has to be, the stationary point has to be what? Has to be x value is 1 plus exponential and y is 1 over exponential. Now again, if you can see the indication here that we have to find in terms of exponential the coordinates of the stationary point. So we have only one point to find. So because of that, we understand that there's only one point that we have to find in terms of exponential. So basically, if you have only one point, that is good for your answer. We don't need this part. We can always eliminate by this. But we have to be careful sometime. In this case, it was okay to eliminate. That's why we can do this. And eventually, you will have this as your stationary point. Okay, and that is the last question of this paper. I hope that was somewhat helpful. As always, thank you for watching. I will see you soon.